Our planet Earth is enveloped by an invisible force field, a magnetic field. This magnetic field is not just a scientific curiosity, it plays a vital role in maintaining the conditions necessary for life on our planet. Imagine it as an unseen guardian, tirelessly working to protect us from the unseen dangers of the cosmos. This field acts as a protective shield, guarding us from harmful radiation, constantly bombarding us from the sun and the depths of space. Solar flares and cosmic rays, which are high-energy particles, would otherwise strip away our atmosphere and make Earth a hostile place for living organisms. The magnetic field ensures that these particles are deflected or trapped, preventing them from causing widespread damage. Generated deep within Earth's core, this magnetic field originates from the planet's rotation and the churning molten iron within its heart. The movement of this molten iron creates electric currents, which in turn generate the magnetic field. This process is known as the geodynamo. It's a fascinating interplay of physics and geology that has been ongoing for billions of years, ensuring the stability of our magnetic shield. The magnetic field extends far into space, creating a region known as the Magnetosphere. This vast, teardrop-shaped area surrounds our planet and acts as the first line of defense against solar and cosmic radiation. The magnetosphere is dynamic, constantly changing in response to solar activity, and it plays a crucial role in space weather phenomena. This magnetosphere acts like a shield, deflecting the constant stream of charged particles emitted by the sun, known as the solar wind. The solar wind is a stream of charged particles released from the upper atmosphere of the sun, known as the corona. When these particles interact with the magnetosphere, they can create stunning visual displays like the auroras, but they can also pose a threat to satellites and other space-based technologies. Without this protective barrier, our planet would be exposed to the full brunt of these particles, with potentially catastrophic consequences for life as we know it. The atmosphere could be stripped away, leaving Earth as barren and lifeless as Mars. The magnetic field is essential for maintaining the delicate balance that allows life to thrive on our planet. The magnetic field's existence is crucial for the habitability of Earth. It not only protects us from harmful space weather, but also helps to maintain the atmosphere and climate that support diverse ecosystems. From lush forests to vibrant coral reefs, the magnetic field plays an unseen yet indispensable role in preserving the natural beauty and biodiversity of our planet. The sun, while essential for life, also emits a constant stream of high-energy particles. These particles, known as solar wind, are a continuous flow of charged particles released from the upper atmosphere of the sun, called the corona. The solar wind varies in density, temperature, and speed over time and distance. It is a formidable force that travels through space at speeds of up to 900 kilometers per second. This solar wind is a formidable force. It carries with it a barrage of charged particles that, if left unchecked, could strip away our atmosphere and bombard the surface with harmful radiation. These particles can cause significant damage to satellites, disrupt communications, and even pose a threat to astronauts in space. It carries with it a barrage of charged particles that, if left unchecked, could strip away our atmosphere and bombard the surface with harmful radiation. The Earth's atmosphere and magnetic field work together to protect us from these dangers. Without this protection, life on Earth would be exposed to intense radiation, making it difficult for any form of life to survive. Earth's magnetic field acts as a shield against this onslaught. This magnetic field, generated by the movement of molten iron in the Earth's outer core, extends far into space and forms a protective bubble known as the magnetosphere. The magnetosphere deflects the charged particles of the solar wind, preventing them from reaching the Earth's surface. When the charged particles of the solar wind encounter Earth's magnetic field, they are deflected. This deflection causes the particles to flow around the planet rather than directly impacting it. The magnetosphere acts as a barrier, redirecting the solar wind and protecting the Earth from its harmful effects. Instead of directly impacting our atmosphere, they are forced to flow around the planet, creating a protective bubble. This bubble not only shields us from harmful radiation, but also helps to maintain the stability of our atmosphere. The interaction between the solar wind and the magnetosphere can also create beautiful natural phenomena, such as the auroras, which are visible near the polar regions. This deflection is crucial for maintaining our atmosphere and protecting life on Earth from the sun's more harmful emissions. Without the magnetosphere, our planet would be vulnerable to the relentless assault of solar wind, making it a much harsher environment for life to thrive. The Earth's magnetic field is therefore an essential component of our planet's ability to support life. In today's technology-dependent world, satellites play an indispensable role. They facilitate communication, navigation, and Earth observation. However, these satellites are highly vulnerable to the effects of space weather, including the onslaught of charged particles from the sun. Earth's magnetic field provides a crucial layer of protection for these orbiting assets. If Earth's magnetic field were to disappear, satellites would be directly exposed to the full force of the solar wind. This could lead to malfunctions, disruptions in communication, and even the complete failure of these critical pieces of technology. The economic and societal consequences of such a scenario would be profound. The most immediate and dramatic consequence of losing Earth's magnetic field would be a significant increase in solar radiation reaching the planet's surface. This radiation, in the form of high-energy particles, can be extremely harmful to living organisms. It can damage DNA, increase the risk of cancer, and lead to other health problems. Without the protective barrier of the magnetic field, life on Earth would be exposed to a level of radiation far beyond what it has evolved to withstand. This could have devastating consequences for ecosystems, potentially leading to widespread extinctions and a drastic reduction in biodiversity. While the loss of Earth's magnetic field would have far-reaching consequences for all life on Earth, humans would face unique challenges. Our reliance on technology, particularly satellite-based systems, would leave us incredibly vulnerable. Disruptions to communication, navigation, and power grids could cripple our interconnected world. Furthermore, the increased radiation exposure would pose a significant threat to human health. The rates of cancer and other radiation-related illnesses would likely skyrocket. Our ability to spend extended periods outdoors without protection would be severely limited. One of the most visually stunning manifestations of Earth's magnetic field is the aurora borealis and aurora australis, commonly known as the northern and southern lights. These natural light displays are not just beautiful, they are a testament to the dynamic interactions between our planet and the sun. These dazzling displays of light occur when charged particles from the sun collide with atoms in Earth's atmosphere, creating a spectacular dance of colors in the sky. The particles excite the atoms, causing them to emit light. This process is akin to a cosmic ballet, where each particle plays its part in painting the night sky. If Earth's magnetic field were to disappear, these auroral displays would become far more frequent and intense. The magnetic field acts as a shield, protecting us from the full brunt of solar winds. Without this shield, the auroras would no longer be confined to the polar regions, but could occur at any latitude, turning the night sky into a constant light show. While beautiful to behold, this constant bombardment of atmospheric particles would be a visible reminder of the invisible danger we would face. The increased frequency and intensity of auroras would signify a compromised magnetic field, exposing us to higher levels of solar radiation. Scientists around the world study these phenomena not just for their beauty, but to understand the underlying processes that protect our planet. The auroras serve as a natural laboratory, offering insights into the complex interactions between solar activity and Earth's magnetic environment. So, the next time you gaze upon the northern or southern lights, remember that you are witnessing a magnificent interplay of cosmic forces, a reminder of the delicate balance that sustains life on Earth. For centuries, humans and animals have relied on Earth's magnetic field for navigation. Migratory birds, sea turtles, and even certain bacteria possess an internal compass that allows them to sense the magnetic field and orient themselves. This ability is crucial for their survival, enabling them to navigate vast distances and find their way home. The loss of Earth's magnetic field would disrupt these natural navigation systems, potentially leading to mass disorientation and confusion among migratory species. Birds might lose their way during their annual migrations, and sea turtles could struggle to find their nesting grounds, the ecological consequences of such disruptions could be significant. While the loss of Earth's magnetic field would undoubtedly have catastrophic consequences for life as we know it, it is possible that some forms of life might be able to adapt and survive. Extremophiles, organisms that thrive in extreme environments, offer a glimmer of hope. Some extremophiles have evolved mechanisms to withstand high levels of radiation and could potentially survive in a world without a magnetic shield. However, the vast majority of Earth's species, including humans, would likely not be so fortunate. The loss of our planet's magnetic field would be a stark reminder of the delicate balance that makes life on Earth possible. The potential consequences of Earth losing its magnetic field are a stark reminder of the delicate balance that sustains life on our planet. The invisible shield surrounding our world plays a crucial role in protecting us from the harsh realities of space. Its continued existence is essential for our survival and the well-being of countless other species. While the complete disappearance of Earth's magnetic field is unlikely, its strength can fluctuate over time. Understanding the factors that influence these fluctuations and their potential impacts is crucial for safeguarding our planet and ensuring the continued existence of life as we know it.